So for video 2 for chapter 7, we're going to look at two different topics. One is sine and cosine values in the different quadrants, and the second are latitude problems, which is an application, another type of word problem. For what you need to know today in terms of sine and cosine, we're going to go back to SOHCAHTOA, which you learned in geometry down here. We really only need the first two parts because we're only dealing with sine and cosine. But if you remember, that's saying that the sine of an angle, or the sine of theta, equals the opposite over the hypotenuse, and the cosine of an angle equals the adjacent over hypotenuse. So if we look at this triangle we have, and I drew in kind of fake axes so you can see it a little better. If theta is our angle, our hypotenuse has to be r, since we have a right triangle over here. Adjacent to that, or next to theta, that's your adjacent side, so that's the x. And the opposite side is the y across from the theta. So when you're looking at these, and the important point here is that if sine is opposite over hypotenuse, in this case, that is y over r. So I'd write these relationships down. These are going to be important for a while. Then the cosine of theta is adjacent over hypotenuse. That, in this case, is x over r. So you need to know that the sine of theta is y over r, and the cosine of theta is x over r. So if we look at this example, it's giving us the point -12, 5, and it's asking us for cosine of theta. Well, we just said that the cosine of theta was x over r. So if we draw in this triangle, there's a right triangle there. This side is -12. Now the distance has to be +12. Distance always has to be positive. I usually say to leave the negatives in there so you don't forget about them later, but we can talk a little bit more about that. This side is y, right? So to get to this point, we went left -12 and up 5. So there are your x and y values. To find the hypotenuse, which in this case is the radius, we could use a Pythagorean theorem. If you can recognize that this is a Pythagorean triple, that's even better. That'll save us some time. But the Pythagorean theorem will get you there. But we know that that radius has to be 13. So for cosine, our cosine is x over r. Well, our x value is going left along the x-axis. That's -12. We figured out that our radius was 13. So what we were looking for, our cosine value, your answer is -12 over 13. And again, it's important from that last side, cosine theta equals x over r, as we have down here, and the sine of theta is y over r. So here's another kind of problem. It says find the sine of theta and cosine of theta at the point 4, -6. So if we take a look, 4, -6, we'll call that down here. If I make this triangle, our x value is 4, our y value is -6, and we have our right triangle. So again, the sine of theta equals y over r, and the cosine of theta equals x over r. So the missing piece here is r. If I go to solve that, we use a Pythagorean theorem, so c squared equals a squared plus b squared. That means c squared equals 16 plus 36. So in this case, c squared is 52. So the radius is root 52. And this turns into a lot of algebra, but what I need to do here is simplify. So inside here, you can write that as 4 times 13. So your c value is actually 2 root 13. So little algebra using the Pythagorean theorem, but we can easily do that to figure out the radius, which in this case is our hypotenuse. So if I write these values in, now that we're dealing with the sine and cosine, the sine is y over r. Well, our y value is -6, right? That's coming down. Our r value is 2 root 13. That simplifies to -3 over root 13. And then if you remember from Algebra 2, hopefully you can't leave a radical in the denominator. So if I multiply both top and bottom by root 13, my final answer, I'm sorry this is a little squished, is going to be -3 root 13 over 13. So that's your final sine value. For cosine, something similar is going to happen, but instead of -6 on top, it's going to start as 4 over 2 root 13. And when you do the same thing and simplify that, your final answer is going to be 2 root 13 over 13. And you can take a minute to check the algebra on that. But those are your sine and cosine values for that problem. And lastly, this problem says find cosine if we know the sine is 3 over 7 and we know that theta lies in quadrant 2. So we know we're in quadrant 2, so we can draw in that triangle. It doesn't have to be perfect to scale. We know theta is in the middle here. If sine of theta is 3 over 7, we know that's y over r. So your r is 7 and your y is 3. Now we need to find what x is in order to find the cosine, because in order to find cosine, we need x over r. So with the Pythagorean theorem, we get 49 equals 9 plus b squared. So if you do the math there, b squared is 40. So b equals root 40, which simplifies to 2 root 10. And we can review simplifying radicals if we need to, but hopefully you remember how to do that pretty well. There were some of those on that warm-up we did for Chapter 7. So 2 root 10 is going in here. The important thing to catch in this case, since cosine deals with the x value in quadrant 2, when you go this way along the x-axis, this is really a negative. And I said that in that opening slide, that distance isn't negative because we can't have negative distance, but the cosine value is negative because x is negative over there. So the cosine of theta in this case is again x over r, so it's negative 2 root 10 over 7. And we can't simplify that. The radical's on the top, so that's okay. So that's your final answer right there, negative 2 root 10 over 7. So for the second topic in this video, we're going to talk about latitude problems. And again, it's an application or another type of word problem. So the problem says the latitude of Santiago, Chile is 32 degrees south. If the radius of the Earth is 3,963 miles, then it asks a couple follow-up questions to answer. If I shrink this down so we have some room. How we're going to think about this is on the coordinate plane. So if I take, for this first question, it says, how far is Santiago from the South Pole? Well, if we look at the Earth like this and we say this is 0 degrees, which it is on our unit circle, so it will be here too. Santiago is at 32 degrees south of that. So we're going to go down and say this is 32 degrees south. We're trying to find a distance to the South Pole. So for the South Pole is obviously going to be down here if this is our representation of the Earth. So this is really 90 degrees. So if I'm trying to find this distance in here, well, that's just an arc length. And since we're in degrees for all these problems, we're going to be able to use theta over 360 2 pi r. We're given the radius is 3963, and that will be, I'll give you that number. I don't expect you to memorize that. But what we need to figure out is what this angle is in here in the middle. So in this case, it's really 90 minus 32, and that overlapped a little bit. I'm really just looking for the inside here, not the whole piece. So that's the angle I'm looking for. So 90 minus 32, that's going to be your theta. So that's 58 degrees over 360. And then it's 2 pi, and again we were given the radius was 3963. And we should expect this to be a big number. In this case it is. We end up with 4,011.71 miles. And our units are in miles because that's what our radius was in there. So that's the first question. If we take a look at, we'll call that part A. For part B, it's saying how far is Santiago from the North Pole? Well, if we look at that same picture, this is the North Pole up here. It's another 90 degrees. So to get from, and I'll do this one in blue, see if we can see the overlap. We want to go from Santiago all the way to the North Pole. So what I'm really doing is taking these 32 degrees in here and adding it to these 90 degrees. So my theta for this problem, I'm going to say S equals, theta again is going to be 32 plus 90. So 122 over 360. And then it's the same thing, 2 pi, and our radius hasn't changed. That is still 3963. So the only difficult part is finding the angle. The rest of it kind of falls into place for you. And that distance we should expect to be longer, and it is. That one is 8438.42. And again, that's miles. For the last one, it says, how far is Chile from Boston? And it tells us that Boston has a latitude of 42 degrees north. So I'm going to draw a fresh picture just so we can see what's going on. So this is 32 degrees south. And we know that Boston is 42 degrees north. So we're looking for this entire angle in here. This video is kind of tough on writing and drawing. I apologize for that, but work with me. So to find that distance, we need to take the 32 degrees down here and add it to these 42 degrees. So when we plug in our formula in this case, our angle is going to be 32 plus 42. So we're going to use 74 over 360. 2 pi, again the radius is 3963. And we get that the distance from Santiago to Boston is a little over 5,000 miles, 5,118.39 miles. So on the website, you'll see the chart. I listed out the problems from each of these sections that you can do. I pulled it together because some of these things we should really do together in class, so we'll start that next week. But do your best on the problems listed, and we'll catch everyone up on Monday.